Hello everyone, welcome to my YouTube channel. So today I've come with a new video on atomic structure, and we are going to cover these three topics today, that is atomic structure, mass number, atomic and mass numbers placement. Okay, and after that, if we have time, if I see that these three topics are covered in very less time, then at last we are going to do balancing. Okay, so first we have atomic number. So for atomic number, at first we have to know one thing, that is what is the fundamental particles, what is means what are shells, and etc. So for this, let us consider an atom as X. Okay, now over here we have, inside that atom X, we have a nucleus. Okay, inside every atom there is a nucleus. Okay, and around the nucleus we have the shells, orbits, or energy levels. Okay, and in that shells electrons roams about. Now there are the three fundamental particles: proton, electron and neutrons. Now the nucleus has proton and neutron, and the shells contains the electrons. So the charge of proton is positive, charge of electron is negative, charge of neutron is neutral. Okay, now in this nucleus proton and neutron is there, and in the shells we have the electrons. Okay, now what is the charge of nucleus? So the charge of nucleus is positive, as if it's plus. Okay, why? Because charge are of only two types. One is negative, I'm writing over here using green pen. One is negative, another is my positive. Okay, one is my negative, another is my positive. Zero, neutral are not at all applicable. That's why it was already crossed out, and these are already ticked out. Therefore, this is my neutron, that is neutrally charged particle. So what we are going to do is we are going to give a big cross mark to it. And for proton, since it's charged particle, then we are going to do we are going to give a big tick mark to it. So we can see that a tick mark is given to proton. So as a result, what we can see, or what we can say rather, that the charge of the nucleus is always positive. Now what is the charge of an atom? Now it's a fundamental one, that is number of protons is always equals to the number of electrons. As a result, an atom is neutral, means it's neutral. Why? Because let us consider an example of plus 2 minus 2. Or suppose let us take an example of, suppose let me take a big number. Okay, suppose 1024 plus 1024. So in mathematics we generally do it that if we see that there is the same number with opposite signs, then we easily cancel it out. And as a result, what happens? The charge becomes 0 or neutral. Right? So charge becomes 0 or neutral. So over here also, plus 2 minus 2, cancelling out 0. So same number of protons, same number of electrons, when cancel out becomes neutral or 0. Now, what is the atomic number? Atomic number is the number of electrons or protons present in an atom. Now, when I'm writing or, we have to keep one thing in mind. What's the reason of writing or? Okay, let me just repeat. When I'm writing or, I have to understand one thing, that what is the reason for writing or in place of and. Because number of protons and electrons are same. So whether I'm writing or whether I'm writing and, both has different meanings. If I'm writing and, then there will be the summation of protons and number of protons, and electrons would have been added if I'm writing and. But since I'm writing or, so it will represent either the number of protons or the number of electrons, and since they both are same, therefore we can easily write or in case of or in place of and. Okay, next coming to mass number. Now what is my mass number? Now the unit of measurement of mass for an atom is AMU, or atomic mass unit. So according to AMU, mass of electron is negligible, mass of proton is 1 AMU, mass of neutron is 1 AMU. So if we want to find out the mass of an atom, then we can easily do the summation of the proton and neutron. Or in other words, what I can say, summation of proton and neutron will give me my mass of an atom. So this is my mass number, and mass number is represented by A. Atomic number is represented by Z. Okay. Now, what is the placement of mass and atomic number? What is my placement? How do we represent that? Placement of, I can also write one more thing, that is representation of or placement of mass or atomic number. So, I am considering one element as X, or an abbreviated form of an element as X, and I am writing Z over here. What is my Z? You can just take a look over here, atomic number, and A is my mass number, and over here we are having charge, right? So let us take an example of calcium, that 40 means 40 is my mass number, 20 is my atomic number. So A 40, Z 20. Electrons will be my 20, proton will be my 20. Why? Because atomic number represent number of protons and electrons. And from the information of mass and atomic number, the number of neutrons can also be found out. How? Let us see. Z is number of protons or electrons. A, that is my mass number, is my mass of proton and neutron. Now whether I am representing proton by Z or I am writing proton does not matter, because atomic number represent number of protons also. So proton can be easily represented by atomic number. Therefore, by using a linear equation, a very important chapter in mathematics, what we can say is n equals to a minus z. Okay, a equals to a minus z. If linear equation is new to you, I will also make a video on it. So, or the concept will be clear for linear equation. Okay, a video will be released soon. So stay tuned about that. So this is my neutron. This is my so we can find neutron by doing A minus Z, that is mass number minus protonic number or atomic number. So over here n equals to A minus Z, that is 40 minus 20. So my answer is 20. So we are getting our electrons, we are getting our protons, we are getting our neutrons. Now let us come to electronic configuration. Now when we are talking about electronic configuration, then just take a look at it. Now it's a very rough diagram. Okay, so when we are talking about an atom, then it has a nucleus at the center. This is my nucleus, right? Around that, from the nucleus, the first shell is represented as K. Okay, from the nucleus, the first shell is represented as K. The second shell is represented as L. The third shell is represented as M, and the fourth shell over here, this one, is represented by N. Now in my K shell, or the first shell, there will be only 2 electrons, and it is applicable. Okay, it's the most applicable one, and it's an important one, and there will be only 2 electrons only. Okay, not more than that. Next, in my second shell or in my L shell, we will have 8 electrons. In my M or third shell, we will have 8 electrons. In my last shell or fourth shell, we will have 2 electrons. There are more shells available in some atoms. Okay, but usually or generally there are only 4 shells, but there are some exceptions where there are more shells, like K, L, M, N, O, P, like that. Okay. Now, in case, suppose over here my last shell was M. Okay, my last shell was M. So, if And in case if the last shell, that is my M, is having 8 electrons, or if it would have been L also, if it have 8 electrons in case, then it will become stable. And that kind of stability is known as octet stability. Okay, and if there are only one shell or there are 4 shell, then the last shell will have only 2 electrons, and that kind of stability is known as duplet stability. Okay, now number of electrons for calcium was 20. Now let us do the electron configuration. So at first we are placing 2 electrons in the first shell, so 20 minus 2 becomes 18. Second shell, what we are doing, 18 minus 8 becomes 10. Then third shell, again we are replacing 8 electrons, and 10 minus 8 equals to 2. And fourth shell, we are having 2 electrons, then it becomes 2 minus 2, that's 0. Now, what is the stability? Stability is duplet state or duplet stability, whatever. Next, let us take an example of aluminium. So over here, charge is given. Now we have to know one thing. When charge is positive, then electrons are given out. Because when electrons are given out, the number of electrons from an atom is decreasing. And as a result, who will rule? Protons will rule. And what is the charge of proton? Plus. So that's why we write plus. In case any atom is taking in electrons, then who will rule? Number of electrons will increase with a comparison with the protons. So as a result, the electrons will rule. And we have to know one thing. Electrons can only move because electrons, suppose this is my nucleus. Around that we have a shell. So electrons will not feel that much consequence, or they does not have to pass through that much consequence. Okay, with a comparison to the protons. Therefore, electrons can easily move out, but protons cannot. That's why number of protons is always stable, but number of electrons varies. Okay. Now this is done. Now let us take one more example, that is aluminium. Already told. So A equals to 13, Z equals to 27, and my charge is plus 3. So proton will be my 13, neutron 27 minus 13, that is my 14, and electron will be 13 minus 3 because electrons are given out. Therefore, it will be 10. Already explained why it is given out. Okay. So this was all for today's video. Hope you have liked my video. If you like my video, please like, share and subscribe it. Also press the bell icon. And in my next video, I'm going to explain you about the balancing, and also I'm going to share one video on linear equations. So till then, bye.